turn the camera towards the actual screen. Rotate it at the top.
Like,
That's good. All right, here we go.
what's the juice in the thingy?
What?
The juice. Like, on the stand there? There's a
It's
liquid.
a level.
What?
A level.
Oh, that keeps it level?
Yeah, when the bubble's in the middle, that means it's level.
All right, here we go. We're gonna draw a bunch of stuff on this periodic table. This is gonna get kind of messy.
Oh.
So can we go get it?
I'm out right at the moment. Any up there?
Get another job.
You should have all this. This is nothing for you.
Oh,
I'm just gonna talk through what things we're supposed to already know. All right, so
It's blocked.
S block, right? Okay.
You should let us like have this on test.
Well, if you talk to AP exam people and they let you have it, I'll let you have it. Do what they do. T block. The ones in the middle. T block. Write these down here.
Yeah.
F block. Okay. All right, SPD and F, you gotta know that. Obviously, we number the rows 1 to 7. Okay.
Yeah.
Let's see here. How many valence electrons are in every element in the first group? They don't have how many valence electrons? Just a number. They have 1. How many valence electrons do these guys have? 2. How about these guys over here? 8, right? Valence electrons, number of valence electrons. You have 8, which means they satisfy what rule?
The octet
rule.
The octet rule. Okay.
can you run over and go?
Highest principal quantum number of electrons in an atom. The ones with the highest energy.
What?
So the valence electrons are the ones in an atom that have the highest energy. The outer shell, highest principal quantum number, however you want to say it or think about it, it's all the same thing. All right, so the first group has all have 1, these have 2, these have 8, which makes them special, right? Let's put them in their own little box over here because they're special. Those are noble gases. They got 8 valence electrons, which means they already satisfy the octet rule. The halogens, this group right here, how many valence electrons do they have? 7. They have 8, and these have 7. How many does the oxygen group have?
6.
6. How about nitrogen?
5.
5. How about the carbon group?
4.
4. The boron group? 3. Okay, good.
So why did I skip the D block?
Because most of them have 2, but there are exceptions.
Well, you told us the exceptions yesterday, didn't you?
No.
I thought you did.
I told you some exceptions to the oxidation numbers, but not their valence electrons.
Okay.
Okay, so we're going to put our stair-step line in here. Okay, what's on the left-hand side of the stair-step line? Metals. What's on the right-hand side? Non-metals. Okay. Metals want to be stable. They like to be like noble gases. One way that they get there is to do what? Lose electrons, which turns them into cations. One way that a non-metal can satisfy the octet rule is to what? Gain electrons, which makes them a anion. Very good. Okay. All right. when these first column metals over here lose their valence electron, what will their charge be? One plus, right? And the second group metals, when they lose their two valence electrons, what will their charge be? 2 plus. These aren't going to lose anything, right? So they're going to be 0. When these guys gain 1 electron, their charge is what? 1 minus. And this group would be 2 minus. Okay, so on and so forth, right? Okay. These have multiple stable ions. The D block metals lose their valence electrons plus some d electrons sometimes. Okay. The P block metals lose sometimes their S and their P, and sometimes they just lose the P. Okay. They do weird things. All right. So we have multiple stable ions for the elements in the D and P block metal groups. Okay. That means they also have multiple oxidation states. Unlike the first group, whose oxidation states going to always be +1, this one's going to always be +2. These are going to always be. This is going to always be 0, -1, -2, right? These can vary. All right, with the exception of silver is always going to be +1. Zinc and cadmium are +2. Aluminum is +3. Yep.
And that's oxidation.
Oxidation. Yep. All right.
Is it just for D metals or is it P metals too? There's not going to be like difference.
What is?
The oxidation state.
They're all different except those 4 right there. They all have varying. They all have multiple states except for those 4. Those 4 will have 1. Okay. Periodic trends. As you go across a period, atomic radius decreases. Ionization energy increases. Electronegativity increases. Okay. As you go down a group, put this around sideways for a second. If you go down a group, atomic radius increases. Ionization energy decreases. And electronegativity decreases. Okay, good with that? Which one of these groups is not part of the electronegativity trend? Noble gases. So that makes fluorine the #1 most electronegative element on the table. Who's number 2?
Oxygen.
Oxygen. And who's number 3? Fluorine. Okay, good.
Yeah, with
All right. Let's see here.
Can you go over the reasons why?
Yep, that was my next thing. So all of these trends here going across a period can be explained by effective nuclear charge. Okay, so the more protons you have, the more effective nuclear charge you have. The smaller the radius, the higher the ionization energy, and the higher the electronegativity will be. Okay? So it's never, the reason why is never because of something's location on the periodic table. Don't ever write that down. Okay? never the reason why. The reason why is the difference in their effective nuclear charge. Okay? Yep.
So is that how we would answer, like if it says to explain, would we just say because of the difference in
Yep.
effective nuclear charge?
So if one has more protons than the other one, they're in the same period. If one has more protons than the other one, it has a greater effective nuclear charge. If the other one has less protons, it has a less effective.
So we don't need to remember like what was on that do's and don'ts sheet.
Yes, that's what I'm getting at. That's
Okay.
basically, if you read the do's and don'ts, that's essentially what their do's are.
Okay.
And their don'ts can be summarized as don't talk about location of ground table. All right, if you're going down a group, it's about energy levels, which equate to distance from the nucleus. So, as you go from, let's just take over here, nitrogen to phosphorus to arsenic to, what is that, antimony or whatever that is. You go down that group right there, the energy levels of the atoms, the occupied orbitals is getting higher and higher. That makes the outer energy levels more distant from the nucleus, okay? Which means their radius is going to be larger, the ionization energy is going to be lower, and the electronegativity is going to be lower. It's because of the distance from the nucleus that is caused by those larger energy levels. Okay. Reactivity, that was mentioned yesterday. Let's see, it's different for metals and non-metals. So for the metals, okay, reactivity, flip it around here a second, reactivity increases going down and decreases going across. For metals, it's the opposite. So going across a period in the non-metal side of the table, reactivity increases. Going down a group, reactivity decreases. So essentially, metals and non-metals do opposite things to chemically react. One gives up electrons and one tries to take electrons. So they're chemically reacting by opposite means. So their trend for being how reactive they are is naturally going to be inverses of each other. That makes fluorine be the most reactive non-metal and francium be the most reactive metal. Time we get down here?
37.
Okay, good. All right, last little fun fact, and we'll look at a couple things on the test. Cations are smaller. Anions are larger. Okay? All right.
Julio's question.
Yep.
What's the reasoning behind reactivity?
It's a combination really of ionization energy and electronegativity, honestly. It's who's pulling electrons the hardest, which is easiest to take one away from. Like francium is not pulling very hard on its, if it's bonded to something, it's not pulling very hard on the electron, but it's very easy to take one away, which is what it wants to be stable. So it's, anytime it gets around something that wants to take an electron away, it's going to very easily allow that to happen. It makes it very reactive.
Can you send me the paper? Well, can I just come over there and take a picture of the paper? I appreciate it. That makes more sense to me. Yeah, I'll send it to you. Don't worry about it.
Okay.
Don't go so far away.
to like the top right hand corner with them Snapchat. Just didn't take pictures of their left eye and crap. It's like a stupid thing.
Oh, what, people snapping each other?
Yeah.
Like snapping each other's ceiling.
That is the dumbest thing that's ever been introduced to our society.
Why is that?
Just taking, I literally could not get to an item in the grocery store that day. Some chick standing there taking, she took, you know, one picture this way, one picture this way, and then one picture, I guess, so we could, you know, see that she didn't have a whole lot of shirt on, and then one picture down here, and I'm like, you just move so I can get a bag of lettuce, you know? Like, you ain't that cute to start with. I don't know who wants to see it, but it ain't me. I'm trying to buy a bag of lettuce. But no, we gotta stand in the middle of Walmart and snap whoever, you know, like, gosh.
So like,
Listen, I gotta update the logs.
There you go. And then you gotta,
Listen, I
you
keep
gotta
walking,
get like, you know,
I keep
the
walking,
top right corner of your head and not the rest of it. You know, you just take a picture of like this part.
It depends,
This
listen,
part,
because if
you
it's a
know.
lot of people, it's usually like an eye. If it's like maybe a couple people, then you'll get like a whole thing.
What does that even mean?
so like, all right, like,
Alright,
I'm
because
gonna break it down. I'm
some
gonna
people
break
are
it down.
judging,
Hold on,
right?
hold on,
I
hold on.
don't care.
Wait, let me break it down. All right, so let's say if you got hose, right?
Right, you all good.
Oh, exactly. Like you gonna see the hose full Facebook, but if it's just like some random, like you gonna see it beside Facebook, like just your eyeball.
Brayden, you can tell me on Snapchat, I don't get to hear what's on the test.
All right, my fault.
Yeah,
All right,
that's
my
what
fault.
I'm saying.
Yeah, hey, Pity, my fault.
We'll explain it later.
What's the rule that says that elements are stable when they have 8 valence electrons?
The Mr. Cato rule.
Octet rule, okay? What's the phrase or term for elements lost, for the electrons lost or gained to make an element stable? What's that term? Oxidation, number, right? Or oxidation state. Yeah, electrons that are lost or gained to make an element stable. All right, what's the Pauli exclusion principle?
They pair up.
The official statement of the Pauli exclusion principle.
Things can't be in the same thing.
The official statement is no two electrons can have the same 4 quantum numbers. That's the Pauli exclusion principle. They have an exclusive set of quantum numbers. What's the Aufbau principle? What does Aufbau mean? It's a German word, right? Build up. Okay, so the Aufbau principle says that electrons build up from lowest to highest energy. Oh my, got all this. Hund's rule. What's Hund's rule?
They don't look the same way.
They don't look the same way. They, what do they look like? I don't know. You have to put 1 electron in each equal energy orbital before you pair them up. Hund's rule is why we put 1 electron in each p, each of the 3 p's before we pair them, or each of the 5 p's, or whatever. Okay. All right, let's see here.
I still think it's
2 atoms that have the same electron configuration are called what?
I don't know.
Isoelectronic. My AP class has a room reserved at the library tonight. Y'all might not get one next door.
8 to 10. We should all go and bomb it.
Don't bomb that. They
Not
got a
no,
lot to
like
study.
not bomb and
Don't
like
bomb their meeting. They got a lot to study.
like not
Really,
bomb
they
and like
really have a lot.
physically speaking, like bomb.
Take the room next door.
No, but like let's go interrupt theirs.
Do not interrupt their study.
Oh.
Shouldn't have told you that.
No, I had already
We just get a study group tonight, y'all.
We did.
Hey, at Gabby crib.
Yeah.
Y'all control, just continue.
So, you remember the quiz we took? We had, all of this information, right?
What?
And you were given 2 orbits. And you
Oh.
were you given 2 orbits, right?
Okay.
And then asked to find a energy of a transition between two of the orbits, and then find the frequency and the wavelength and all that, right?
Right.
Right.
And have
Next
that
day.
quiz back, that's a whole nother set of questions about that. Okay, then there's, so here we go, 4 atoms, I'm gonna give you 4 elements, okay? I'm gonna ask you basically the same questions about each one of them. I'm gonna ask you to draw the orbital diagram, I don't care if it's shorthand or not. I wanna ask you how many valence electrons it has. I'm gonna ask you to draw the orbital diagram for the stable ion of that element. There might be more than one right answer to some of those. And I'm going to ask you for the oxidation state of that element. There might be more than one answer to that. And then I'm going to ask you to give me the 4 quantum numbers of the last electron in that element. Okay, repeat that 4 times. 2 metals, 2 non-metals. So orbital diagram, valence electron, stable ion, oxidation state, quantum numbers. Okay. That 4 times. Then there's a couple of little questions, almost just like what you just took on that quiz. And then there are 2 questions that ask you to explain a periodic trend, and then there are 5 bonus questions, of which I will not tell you anything about.
All right. One of the questions is, what type of picture did the lady take in the Walmart when he was trying to get the lettuce?
Right.
Or no, the question would be,
Wait,
what was
do
I
we
trying
have
to
any-
get?
Do we have anything on the,
You should ask.
scientists?
What?
Any questions on the scientists?
Yep, all the scientists